20 years ago, I started photographing our oldest trees. They can be 4,000 years old. Some are dying from disease, insects, lack of rain, warming temperatures. Never did I realize that within my lifetime I would be recording their deaths.
It's really astonishing in a forest the extent to which the trees produce a canopy that is fairly uniform, fairly dense. They parcel out the space up there among themselves as though they had decided ahead of time, you get this space and I get this space. They don't really think of it that way, but that's the way it works out.
Trees are miraculous in other ways too. As they reach out with their leaves and branches, they play a vital role in the health of the planet. Through photosynthesis, they help regulate Earth's temperature by pulling carbon dioxide, a powerful heat-trapping gas, from the atmosphere and emitting oxygen. Since carbon dioxide warms the atmosphere, by removing it and storing much of the carbon safely away in their branches, trunks, leaves, roots, and soils, forests help cool the Earth. In fact, every year, terrestrial ecosystems remove about 30% of fossil fuel emissions, and forests are responsible for most of that. But that percentage is decreasing as emissions increase, steadily raising Earth's temperature and threatening forests' ability to offset the warming.
We have warmed the Earth by a full degree and a little more, and forests are suffering increased hazards of fire as they get warm and dry, increased hazards of disease as they become vulnerable to insects, and dying as a result.
As trees die, they become part of a dangerous feedback loop kicked off by the warming. As the temperature rises, the climate becomes hotter and drier, and they fall prey to drought, fire, and insects. With fewer trees left, more heat-trapping gas remains in the atmosphere, raising the temperature higher, resulting in even more dieback. As trees burn and decay, the carbon they've locked away during their lifetime, what scientists call a carbon sink, is released back into the air.
It's entirely possible we reach a point where we're killing off forests much more rapidly than carbon can be fixed by forests. The net result then is to produce a feedback that's lethal.
Today, we have a choice. Allow trees to do their job and cool the planet, or jeopardize the forests we have. That's the path we're on right now. How we protect and manage forests will play a large role in determining our future. When it comes to global warming, three major forests matter the most: the tropical, the boreal, and the temperate. No forest is more critical for cooling the planet than the Amazon. Spanning more than 2 million square miles across 9 countries, this tropical forest has been storing carbon for millennia. Yet it is dangerously close to releasing more carbon than it absorbs. Mike Coe is the director of the Tropics Program at the Woods Hole Research Center. For over 20 years, he's studied how deforestation in the Amazon rainforest affects the local climate and environment.
Tropical rainforests probably account for about 15 to 20% of all the terrestrial carbon sink, and the Amazon's half of that. So we're talking about a significant fraction of our annual emissions are being taken up by the Amazon forest.
But in the last 50 years, nearly 20% of this forest has been lost, mostly to slash and burn land clearing, triggering fires, insects, and tree dieback. This not only releases the carbon stored there, it jeopardizes an important cooling function of the Amazon rainforest. During transpiration, Roots pull water out of the ground and release it as water vapor through tiny holes in the tree's leaves, creating a cooling effect on the surrounding air. In the Amazon, transpiration can cool the region by as much as 10 degrees Fahrenheit.
When we lose trees in the Amazon, when we cut them down, what we're doing is we're shutting off that transpiration. So what you get is a drier climate. And the more you deforest, the drier it gets.
Over the past 2 decades, the dry season has extended several weeks, stressing trees even more and creating an ideal environment for fires to spread.
During extreme droughts, a huge amount of the forest burns. That turns the forest that year from a net sink to a net source of carbon. And we can do the math. If that happens 5 times in a decade, this forest is now a source.
Today, tropical forests are absorbing 1/3 less carbon than they did in the 1990s. Scientists predict that with the loss of so many trees, the Amazon could flip to emitting more carbon than it stores as soon as the next decade.
You can imagine that the climate's changing a little bit and everything looks just fine. But then one day, it changes just enough that the whole system flips over. You know, it's the classic frog in the water that you heat up. The frog's not noticing anything until it's way too late.
The next major forest at risk of tipping from a carbon sink to a carbon source is the boreal, encircling the North Pole through Siberia and North America. The largest forested region in the world, this vast coniferous expanse, stores an estimated 2/3 of all forest carbon, most of it locked away in frozen plant and animal remains deep in the ground. But that's changing. As with tropical forests, the warmer, drier climate here is making the trees more vulnerable to disease, insects, and fire. Brendan Rogers has been studying how boreal forests respond to climate change for the past decade.
Wildfires are getting worse across the boreal zone. We're seeing more and more large fire seasons, record-breaking fire seasons every year.
Unlike in tropical forests, the fires here strip off the insulating ground cover, preventing it from building up in between the frequent burns. Without this protective layer, fires reach further and further down, burning the organic matter stored in the soil.
About 75 to 90% of all the carbon stored in these forests is underground. And that is actually the majority of the carbon that's getting released from these fires.
The fires kick off a feedback loop, triggered by warming in the boreal zone. More fires burn carbon deeper down in the soil, releasing carbon dioxide and methane into the atmosphere, heat-trapping gases that make the climate hotter and drier, leading to more wildfires. Like the Amazon, the boreal forest is going to switch from a carbon sink to a carbon source. Scientists don't know exactly when, but predict that at the current rate, it will happen by the end of this century, crossing a tipping point that the forest can no longer recover from.
We're seeing rapid change now, so rapid that the system is essentially not used to it. And the scary thing is not knowing where that tipping point is.
The temperate forest makes up only 1/4 of the world's forests, but it's our best hope, since the tropical and boreal forests are on the brink of becoming emitters of carbon. Once cleared for agriculture, many temperate forests in the US and Europe have made a comeback in recent decades. But in the southeastern US, old forests are being cut down by the wood pellet industry for burning, releasing decades of stored carbon back into the air. Even though these forests are being replanted, when it comes to offsetting global warming, old and young forests are not equal. Beverly Law has been measuring the exchange of both carbon dioxide and water between our forests and our atmosphere for the last 25 years. She works at 2 long-term testing sites that are part of a global network of more than 500.
An older forest has a lot of carbon stored compared to a younger forest. In a young forest ecosystem, There aren't that many trees there, and they're not taking up much carbon from the atmosphere.
Old-growth forests in the Pacific Northwest store huge amounts of carbon. Not only are they thriving in the wetter and cooler climate, these forests will be less vulnerable to climate change over the next 30 years compared to other forests in the western U.S.
If I were to try and mitigate climate change, the best strategy is when you have forests that have low vulnerability to climate change in the future, and they store a lot of carbon already, is keep those forests like they are, preserve them.
But unfortunately, these hardy carbon-rich trees have been prized by loggers for centuries. Redwoods that once towered over the Pacific coast are now mostly gone. When a tree is logged, 1/2 to 2/3 of the carbon it stores is released through decay or burning of the unused branches, leaves, and roots, as well as from the surrounding soil. Today, 17% of global carbon emissions each year can be attributed to logging and burning wood pellets for bioenergy.
In Oregon, of all the forest that was harvested over the past 100 years, 65% of that carbon has gone back to the atmosphere. Now, this is just the wrong time for that in terms of climate.
The warming atmosphere poses another kind of threat. Unable to survive the higher temperatures, many forest species are migrating north to cooler climates. But not all species can do this, and it takes time, which is in short supply. With the clock ticking, it comes down to how we manage temperate forests. Use them for commercial purposes, or keep them intact to cool the planet. While human activity has kicked off natural warming loops, human ingenuity could reverse their direction, turning them into cooling feedbacks instead. It would mean protecting and expanding forests, preserving marshes, grasslands, and all natural habitats. Using agricultural practices that store carbon instead of releasing it, and letting trees and plants do their job of taking carbon out of the air. This would lower Earth's temperature and kick in a self-perpetuating cooling feedback loop. George Woodwell was an early pioneer warning about fossil fuel use, setting off warming feedback loops 5 decades ago. He's convinced the solution lies with nature's own ability to cool the planet.
We can store carbon in life. If we want to be optimistic, we have to be very progressive in our transition away from fossil fuels and into a new green world. But it takes imagination, interest, and a recognition of the reality of an Earth that is failing at the moment. We can't allow it to be too late.